What's up, y'all? Today's lesson is Module 4, Lesson 4. Can't touch this. Our objective for today is to identify, define, and draw parallel lines. Last time we talked about perpendicular lines. Those are lines that, when they touch, they create a perfect right angle. So you might see it like an L, or an upside down L, or a backwards L, or maybe an uppercase T, or maybe a lowercase t, or a cross, you might say. But notice they create these squares, right? Those angles are perfectly right angles. Those are 90 degrees. That's the measurement of those angles, how wide apart those lines are. Today, complete opposite, parallel lines. What are parallel lines, you say? Well, think about two roads that run side by side and never touch. We're going to do a lot of work with that today. So at this point, make sure you're done your Dreambox lesson. Make sure that you do your fluency, your number gym, and your mix and match. And we're going to jump right into our guided practice. Let's go.
What's up, mathlete? Let's start our day with some math exercises. Model array. Now, in the other direction. Model a line. A point. Model a right angle. Nice job.
All right, very quick review. A line goes on in both directions forever. You know, because it has two arrows, one on the left and one on the right, or it could be up and down. It could really be any direction, but it needs to have two arrows on either end. A line segment has, it looks like a line, but it has two endpoints, so it stops on both sides. That's a line segment. Array stops at one side and goes on forever in the other direction. It could also look like this. So it's got one endpoint and one arrow. Those are rays. And then last but not least, our pal over here told us about a right angle. That's like the corner of a square. And we know, because it's marked off with our right angle symbol, that has a degree of 90 degrees. 90 degrees, all right? That's the measurement. Those are all really important. Lock those into your memory. I would study that for like 2-3 minutes. Make sure you have it committed to memory. Let's move forward.
Start Zearn.
All right, we won't need these note pages, but we will need a piece of paper. A lined piece of paper would be really cool today. Let's see if I have one around here. Give me 1 second, my friends. All right, y'all, I'm going to use my notebook. Notice lined paper. Those are parallel lines. Look how many. We're going to find out why those are considered parallel lines in a second. So just make sure you have a piece of scrap paper. If it's lined, even better. Put your ruler on the drawing area, then trace the two long sides of your ruler. So if you don't have a ruler, that's okay. What you can do is, if you have lined paper, you can pick two lines and carefully outline those two lines. So I'm going to do one in pink. It's got to be as straight as you can make it. If you do have a ruler, you can make two. You can outline the two edges of the ruler. I'll do one in pink. I'll do one in blue. Check it out. How do they look? Do they look straight? I think they do. All right, go ahead and make your own. And then we'll move on. Do the lines touch? What do we think? No. If the lines continued, would they ever touch? So let's say, hypothetically, or just pretend, They go on forever, off the page, around the room. Would they ever touch? No, they wouldn't. They would continue in the same directions without ever touching. Are these lines perpendicular? Think about it, answer, and then check your work. Well, perpendicular lines look like this, right? Or like this, or like this. They create 90-degree angles. Do we see any 90-degree angles here, or are they just straight lines? They look straight, so no, these are not perpendicular. Do they make any angles? Do we have any angles here? Nope.
Lucas, how did you draw your lines?
Like this.
Nice. Do the lines touch?
No, even if they continued, they would never touch.
What else did you notice?
They're not perpendicular because they don't make right angles. They don't make any angles because they don't touch.
That's right. You've discovered parallel lines. Two lines that never touch, no matter how far you extend them, are parallel.
All right, this is a key concept. We learned about perpendicular lines. The other type are parallel. I would write this down in your notes. Those are lines that are separate, but they run in the same direction. You can think about the sides of a road. You can think about the sides of your pencil. You can think about the edges of a binder, each edge, right? They'll never touch. You might have parallel roads, right? You might have your street here and your friend might live on this street and they run parallel to each other. No matter how far you extend them, they never touch. They always maintain the same distance from each other. Parallel lines. That's key for today. I want you to write this down in your notes. Parallel lines never touch no matter how far you extend them. Write that down. You're going to need that for your exit ticket. You might want to pause the video while you're writing now. All right, y'all. Let's move forward.
Check out this letter W. Are these diagonal segments of letter W parallel?
So are the outlined, and we'll do a different color. Let's do pink. Are these parallel? What do we think? I think yes, because if we only looked at those two by themselves, they would go on forever without ever touching. They would never intersect. So yes, they are parallel. How about these two lines? This one's tricky because they're not touching, but are they parallel? Well, if they continue forever, it looks like they will eventually touch. And if at some point along their lifespan, their trajectory, if we think about where they'll be in the future, if they look like they will touch, then they are not parallel. Nope. They're what's called intersecting lines. Not perpendicular because they don't create, there's no right angle here, but they're intersecting. Great job.
Sophie?
This diagonal line segment and this diagonal line segment are parallel because if you extend both lines, they'll never touch each other.
That's right. What about these?
They aren't parallel.
Why not? I don't see an intersection. Sophie?
If you made each one longer, they'd run into each other and intersect off to the right.
That's right. When we're looking for parallel lines, we have to think about whether the lines will ever touch each other, not just in the part we can see. Now, you guys know I love taking pictures when I'm exploring New York. Let's check out some lines in my pictures. Can you guys help me find parallel lines in these photos?
All right, let's take a look at these photos very quickly. We'll look at the first one. They look like three pillars, and it looks like they're fairly parallel. They run in the same direction. So I would say yes. Let's put a check mark. All right, here we have the top of a building. It's very pointed. They intersect at the top. Because they intersect, no, they are not parallel. And our stairs, if we look at the edge, we'll do it in green. If you look at the edge, notice the edge of these staircases all run parallel. They're all in the same direction. They never intersect. So yes, put a check mark. That is parallel.
Lucas, where'd you see parallel lines?
The pillars in the first photo are parallel. Even if we extend them, they never intersect.
That's right. Sophie, how about the church steeple?
Those line segments in the steeple aren't parallel. If we extended them, they would intersect. But the stairs are parallel.
Nice job, guys.
All right, nice work, my friends. Let's move forward.
Let's use the word parallel in sentences to describe what we've observed about parallel lines so far.
All right, so we have a little true or false activity here. We have three sentences. We have to see if they're true or false. Let's read them together. Parallel lines are perpendicular lines. Are they? No, they're not. They're completely different. In fact, they're opposite. So this is false. That is not true. Parallel lines are always the same distance away from each other. So that means they always are the same distance away from each other. That is true. They have to be, otherwise they would intersect at some point. And then parallel lines are side by side without touching. That is true. Nice job.
Lucas, what have you noticed about parallel lines?
They are side by side and never touch.
That's right. Sophie, anything else?
They're always the same distance away from each other.
Nice observations.
Are these lines parallel? What do we think? Yes. They're side by side, they don't touch, and they're the same distance apart forever. Are these lines parallel? Let's touch them if they are. They are. And so when you have parallel lines, we use arrows like this to show that they run in the same direction. So these two lines are parallel, and we know because we use those two arrows there. That's important to remember, my friends.
Since the two lines are the same distance from each other at all points, we know that they're parallel. On the grid paper in your notes, use your straight edge to draw rectangle A, B, C, D like mine.
All right, y'all, so we have to draw rectangle ABD on the grid. We don't have this grid paper, unfortunately. That's okay. We're going to use their example here. Let's move forward, but pay close attention to what they have drawn. Is there a line segment in the rectangle that's parallel to AB? Let's take a look at AB. Line segment AB. Right at the top, is there another line segment that's parallel to AB? I think I see one. Which segment's parallel to AB? Well, AB is right up here. So we know AD it touches it. So if it intersects, it's not parallel. Same with BC. So the only line segment that could be parallel is DC at the bottom. Look how it runs parallel. If I put arrows, it would run in the same direction forever. Forever, as my friends from the Sandlot used to say. DC is parallel to AB. Great job.
Lucas, do you see a segment that's parallel to AB?
Yes. Segment CD.
Let's check to make sure the segments are parallel. I can measure the distance between segment AB and CD at each endpoint and make sure they're the same. It's 5 inches from point A to point D and 5 inches from point B to point C. So we know segment AB is parallel to segment CD. Use this symbol to record another parallel pair of line segments in the rectangle.
All right. All right. So A, B, and C, D are parallel. So we need to know what's another pair, which means two, right? A pair of something, of parallel line segments in the rectangle. Well, if we used AB, we only have two more. So let's do a different color. We'll use pink. What about AD and BC on the opposite sides? It looks like they never touch. They would run alongside each other forever. Same distance apart. It looks like AD and BC are indeed parallel. Nice job. What do you notice about the sides of a rectangle and parallel line? So we have a rectangle here. It's a rectangle because it has 4 right angles. Opposite sides of a rectangle are parallel. Opposite sides are parallel. So our top and our bottom, and then our left and our right. Opposites will be parallel. Nice job.
What's another pair of parallel line segments in this rectangle?
AD and BC.
That's right. This is how we'll write that these segments are parallel. What do you notice about opposite sides of a rectangle and parallel line segments?
Opposite sides of a rectangle are parallel.
That's right. Is this true for all rectangles?
So, if you notice, it doesn't matter which way they're flipped, which way they're oriented. If it's a rectangle, opposite sides will always be parallel. They'll always run in the same direction. Notice I'm putting my lines here to represent that. We'll do green for this one. So this side and this side are parallel, and then these two sides are parallel. So yes, opposite sides of all rectangles are parallel. Nice job.
Lucas, does the size of the rectangle determine whether or not its opposite sides have parallel lines?
No. Opposite sides of all rectangles are parallel.
That's right. Nice thinking. Let's practice drawing more parallel lines.
All right, my friends. First, use your straight edge to draw the horizontal line X, Y. What I would do, I would get a new piece of lined paper if you have it. If you don't, you can use a straight edge, like a piece of you could use a ruler or a folder. I'm just going to use this lined paper because they're already perfect lines. And I'm going to do a point on one side, X, and a point on the other side, Y. And I'm going to draw a line between them, just like that. Check it out.
Here's my line XY. To create a line parallel to this, I'll measure 3 inches down from point X and 3 inches down from point Y. Then I'll use my ruler to connect them. Now you give it a shot.
So let me grab a ruler. The reason a ruler is helpful is because we can make sure that both of our line segments at every point are the same distance apart. So I'm going to take my ruler and I'm going to draw a line a point 3 inches from X, straight down. 3 inches from that straight down. I'm going to do the same thing with my Y. I'm going to draw a point 3 inches down. Boom. 3 inches down. I measured it, and then I'm going to create a line across connecting those 2 points. Check it out. Boom. And I just created parallel lines. Woo! They should be perfect or close to it. We'll call that one, I'll name it ST. ST. I want you guys to try to create your own. Try to make them as straight as you can. See if you can create your perpendicular, your parallel lines. And you know they're parallel by finishing them off with 2 arrows right in the middle in the same direction. Nice work.
Sophie, how did your line end up looking?
Like this. I labeled it ST, and I used the parallel symbol like this to show that line XY is parallel to line ST.
Really awesome stuff, guys. You can also draw arrowheads on each parallel line like this to signify that these 2 lines are parallel.
All right, my friends, this symbol right here, that's the parallel line symbol. So if I have XY and I drew that, that means that these 2 lines are parallel to each other. We talked about perpendicular last time. This is the symbol for 2 lines that are perpendicular. It looks just like that, an upside down T. Nice job.
Today we practice spotting and drawing a lot of parallel lines. We're going to keep practicing those lines in the Tower of Power.
Nice job. All right, your job now is to head over to the Tower of Power. You're going to complete that on your own. You guys are Zearn experts, but if you need help, you reach out to me. We'll figure out a way for me to contact you. I can call you. We can do it on Google Classroom. We could set up a Zoom, but I want to make sure that you're getting all the help you need. But you got to reach out. You let me know, and I will be there. Put up the bat signal, right? The Mr. Prada signal. All right. Once you're done that, you're going to head right over to your Edge Elastic assignment. So why don't you pause the video now, do your Tower of Power, and then I'll see you in a second for your Edge Elastic exit ticket. All right, y'all, it's time for our exit ticket. So we have 4 questions today. Question 1, in your own words, describe the difference between perpendicular lines and parallel lines. I hope you've been watching the YouTube video because we've talked about this a lot, right? So you can go back and check that out if you need to. But think about parallel lines and perpendicular lines. What are different about each one? If you want to define both to answer this question, that's fine. You want to answer this in at least 2 complete sentences. For question 2, identify the following pair of lines. Are they parallel? Are they perpendicular? Or are they just touching? Are they neither but just touching, which is intersecting? So you're going to choose one of these 3. For 2, are these parallel, perpendicular, or intersecting? And then that's 3. For 4, again, are these parallel? Are they perpendicular, or are they intersecting? And I'll give you a little clue here for the last one. This creates a right angle. They create 90-degree angles here. All right, that's it for your exit ticket. Again, good luck. If you need help, reach out. I'm proud of y'all, and I will talk to you on the flip side. Peace.